Good evening, welcome everyone. Welcome everyone here in person at the Italian Academy at Columbia University. Welcome everyone online. My name is Christoph Meinrinken. I'm a professor of practice here at Columbia. I'm also the academic director of the Information and Knowledge Strategy program here at Columbia. We refer to it usually as IKNS. We run the IKNS Seminar once a semester. We always try to bring a thought leader to campus about a timely topic. The events are really open to the public. They're for everyone. So we have students here, alums here, Columbia faculty here. We also have quite a few industry professionals from around New York City. For example, just to name a few names, healthcare service corporations here tonight, Deloitte, Amazon, of course, Société Générale, a sustainability startup, and I could not believe it, also apparently someone from my favorite bakery chain in New York City. Tonight it's my honor to introduce our seminar speaker, Kathy Koons. Kathy Koons is faculty here at Columbia. Most recently she was the global head of data and AI in healthcare and life sciences, specifically at Amazon Web Services. I thought I would spend a moment to explain why and how Kathy is faculty here, because it shines kind of an interesting light on why, how, and what we teach in IKNS. So I think 2 or 3 years ago I was kind of faced with a conundrum because one of the rock star instructors for our course Business Analytics was retiring. Jeannie Harris, she wrote several textbooks on business analytics in the world, consulted many multinationals on business analytics. So I thought, okay, so we're going to take over the course, we're going to find some new instructors, and what I really wanted to bring into the course and continue into the course, what Jeannie Harris had started, was not just the question of, okay, we're going to have a bunch of smart data nerds, geeks, setting up a wonderful business analytics system for the company, but then also do, and that's very much something we teach in IKNS, and when I spoke with Kathy, you mentioned those three words, last mile of analytics, and that really stuck with me because it's then this art, rather, of once you have devised this beautiful system, how do you get it such that people actually use it, that people trust it, that people know what to do with it, that people take action on it, and that it fits with the culture and the DNA of the organization. So you can actually reach lasting change, if I'm paraphrasing more or less correctly. And while researching that, I came across Kathy Koons' webinar here, Kathy Koons' blog post there, and that's how it all started. So with that, again, it's my honor to introduce you tonight as your speaker, as our speaker, and I'll leave you to it.
All right, thanks, Christoph. All right, it's great to be here. See some new friends, some old friends. Really look forward to chatting with everybody afterwards at the reception. But as Christoph said, Kathy Koons, I'm a lecturer here at Columbia in the IKNS program. I really have enjoyed my first semester, and really I learned a lot. I will say my students have been very gracious with me, and so any of my students who are here or watching, thank you so much. I have learned a lot from you, and next year's students will benefit from this. So I always love to continue learning. But really what I wanted to share with you tonight is, we've all seen, experienced, interacted with generative AI capabilities. And they can be cool and they can be fun, and you can, have them write a haiku for your dog or help you draft an apology letter or, all sorts of fun things. But what I wanted to share with you is a couple of examples of how generative AI is helping to transform organizations. And the two examples I'm going to share tonight are actually aspirational, art of the possible use cases that I worked with organizations when I was with Amazon Web Services. Now, these things I'm going to share are down the road away. But you'll see how really using traditional business analytics and linking them together with generative AI can help transform organizations and move them to a new level of profitability, service, and sustainability as well. So here is our agenda. Don't hold me to the timing, but I like to put this on here just so that I can keep myself on track. Talk a little bit about setting the stage for generative AI. Talk about how, really, where did generative AI come from, and what is the evolution? I'll share with you these use cases that I'm talking about. Talk a little bit about the barriers and why everybody isn't doing it, and then a little bit of what organizations can do to move ahead and create generative AI success, and then just a few key takeaways. Want to leave plenty of time at the end for Q&A. Before we get to the use cases, I want to talk about a concept that many of you will recognize from your own work life that I call the swivel chair problem. You're a highly skilled professional, you're at your desk, you're surrounded by multiple screens and systems, you receive an alert in one system, swivel your chair to check data in another system, swivel again to document your findings in a third system, and finally swivel once more yet to take action in yet another platform. So it's not just the physical movement, right? It's cognitive whiplash. Each system has its own interface, its own logic, its own language. This human in the chair becomes the integration point. The human is basically an API transferring information between disconnected technical domains. And so the cost of this approach, you see, are enormous, but really invisible on balance sheets. Studies show that knowledge workers can spend up to 30% of their time in this digital paper pushing, and the error rates increase with each manual transfer. Perhaps most critically, valuable context is lost at each boundary crossing, right? So really, what was the information that you saw in that alert? What information did you gather and look at and consider when you made that decision? Did you accurately enter that information in that third system that was your platform, your system of action? And so there's, a lot of risk for error and context that's lost. And what is really an additional layer of challenge on this is this problem exists even in highly digitized enterprises. And in fact, sometimes digital transformation initiatives actually worsen the problem by adding new specialized systems without addressing the integration challenge. The average professional today navigates between 5 to 15 different systems daily. I was working recently with a large top 10 property and casualty insurance company. They said that their call center reps have to log into 15 different systems just to start their day. And so the cross-functional processes that involve these multiple departments just multiply this effect. And as technical debt accumulates, these disconnections become institutionalized. And so this is precisely where generative AI creates transformation rather than just incremental improvement. It can act as an intelligent bridge between these systems, right? Maintaining context, translating contextual boundaries across different domains and systems. And so as we look at our case studies today, think about how GenAI doesn't just automate individual tasks, but can eliminate entire categories of swivel chair activities. And this frees people up to focus on the valuable work that actually requires human judgment and creativity. And hopefully I'll be able to bring that out in the stories with these use cases tonight. And so the two use cases I'm going to talk about are supply chain resilience and predictive maintenance optimization. And so supply chain resilience was working with a top 5 med tech manufacturer. This manufacturer has a global inbound supply chain with various electronic parts, components, sub-assemblies, some of which are, commercial off-the-shelf products, some of which are custom built and configured as sub-assemblies for their equipment. This company, almost all of their products are so complex that they are they are configured to custom specifications for the customer. So they cannot be produced en masse. They need to be able to produce in more of a just-in-time way based on that specific healthcare provider's requirements. And so the need to link together a very robust and accurate forecast and planning process with a flexible inbound product supply chain with connection into the engineering group who will be choosing from different components based on the customer specifications, feedback that they're getting from quality reports, those sorts of things is critical. And so, when I talked about that swivel chair problem, we've got planning, we've got buying, and we've got engineering. And all of this is reliant on parts and assemblies that are coming from all around the world. Before we get into these use cases, though, let's think about how we got to where we are with generative AI, right? They didn't emerge overnight. And it may seem like for those of us who aren't following all the latest machine learning news or how the latest Turing test is going, it seemed like ChatGPT came out of nowhere. But if you think about the predictive analytics that organizations already use, churn prediction, demand forecast, risk assessment, these systems require structured data, careful feature engineering, and they produce specific limited outputs, right? It is one model to solve one question. And, while they can be very powerful, these traditional systems have some inherent limitations. They're designed to solve specific, well-defined problems. They require clean, structured data. And they typically need human expertise to design, train, and maintain. So you think about the Turing test was proposed in 50. Neural networks were first conceptualized that laid this groundwork, but they were not actually available. And so, we move into this age of deep learning. Deep learning and neural networks marked our first major evolutionary leap. And these systems could process unstructured data, text, images, audio, and didn't need humans to manually define the features. And this was revolutionary because it meant systems could analyze content more like humans do, recognizing patterns in raw data rather than requiring pre-processed numerical features. And so as these networks grew in size and complexity, such as these generalized adversarial networks, they became increasingly capable of understanding nuance and context. But they were still primarily designed to classify, predict, or recognize, and not compete. But then when the transformer architecture became available, this enabled systems to process information with a much deeper understanding of relationships and context. And that is really what opened up generative AI. The large language models built on these architectures didn't just classify text, right? They could generate it. And as these models scaled, they developed emergent capabilities beyond what they were explicitly trained to do. And so the shift from models only, that could only complete predefined patterns to systems that could reason, infer, and create, such as GPT-3, right? This generative pre-trained transformer, is really the birth of generative AI as we know it today. And so it's really exciting to see these capabilities now evolving into enterprise-ready solutions that don't exist in isolation, but enhance and connect an organization's existing system. And so, the GenAI revolution begins. ChatGPT is introduced, and everybody's mind is blown with all the things that they can do with ChatGPT. But let's talk a little bit about some of the other uses of generative AI. You've got your supply chain buyer, right? They need to monitor their supplier dashboard, their supplier conformance dashboard, and they see that a supplier is trending out of compliance with their contractual obligations, which will put, ultimately, deliveries at risk that they have made commitments to customers. Now, traditionally, when this would happen, the buyer would have to go into a system and look at other alternative suppliers, do a lot of research on these suppliers, what their capabilities are, what their certifications are, where these suppliers are located, and make a lot of judgment calls as to which supplier they should, pivot to source these parts from. They would then have to, review the PO, the contracts they had with those suppliers, make some decisions on, okay, if we don't get these, I'm going to have to pay more to get these parts in to meet these customer commitments. So I either have to choose to miss a customer commitment and undermine our customer satisfaction and our revenue stream, or I have to choose to erode our margins so that I can meet that, right? So not an ideal situation. And so in the current state, right, they've got this fragmented performance monitoring that they have to stay on top of across different systems. Then they've got these disconnected analytical systems that they may be, they have to look at different systems to get their different predictions that they then, back to this human API, have to integrate and make judgment calls on what they think is going to be the best option. Then they have to be the ones, oftentimes, through a ticketing system, through an email, through a spreadsheet, have to send notification to engineering that there has been a change in this supplier, and here is the new supplier that you need to load into your engineering system. And so, there's risk for miscommunication. There is risk for the engineers not being aware that this is a new supplier. The buyer is swiveling between their performance systems, their alternative supplier databases, their pricing models, their delivery tracking tools, and more buyers are having to consider carbon impact. So then there's another carbon impact calculation of where is this produced and what factory is it that is going to assemble this. Each system, different interfaces, different credentials, specialized knowledge. The manual data transfer between the departments, right? They have to extract the supplier specifications, share it with engineering. The configuration engineers receive this not in their workflow when they are configuring this, but it introduces another swivel to the engineering team. And so, again, the critical context decision criteria is lost during these handoffs. So think about the future state, right? So in the future state, the buyer receives this alert that the supplier is trending to miss their delivery commitment. The generative AI model has already been monitoring that, identified this trend, reviewed what is in the alternative supplier database, pulled pricing data from their ordering system with the supplier, analyzed the forecasted orders and the committed orders that include this part and presented to the buyer, here are the top 5 suppliers or the top 3 suppliers for these parts. Asks the buyer, would you like to optimize on margin, on assurance of supply, or carbon impact? The AI system, the generative AI agent, could also identify this customer whose order might be had an order impacted last quarter. You should be aware of that, right? So all sorts of information that is scattered across contextual systems, the generative AI agent can pull that together and then present it to the human, who can use their creativity, their strategic thinking, their contextual knowledge and awareness that they have that is outside of the data within this organization's systems to make the best call, right? And then automatically feed that into the engineering system so that as the engineers are designing, then that information about margin, that information about carbon impact, that information about quality and reliability of this supplier is available for the engineers as they are configuring these products for their customer. Now, when we think about generative AI, I've had a lot of people ask me, well, now that we have generative AI, do we still really need the more traditional analytics? Do we need, dashboards and predictive models? And my belief and what I have seen emerging is that generative AI's, a lot of the value and the transformative value of generative AI is taking the information that already exists within many of these more traditional dashboard and predictive analytics and carrying the information from one to the other, being the monitor, alerting, providing additional context, additional information, and using a generative AI agent as the connector across these different predictive analytics capabilities so that the information from the different predictions and the different measures can be brought together with the AI agent providing some initial recommendations of action that the humans should take. And the generative AI, transformation, right? What does it enable in this use case, right, is the swivel chair elimination between the supplier monitoring, the alternative sourcing, and the engineering configuration systems. Giving a natural language interface for criteria refinement, right? Which of these has the highest margin? Which of these has the highest quality scores? Not having to navigate across those multiple systems, but having a generative AI agent to be your single interface across these different systems. Synthesizing multiple data sources and systems, right? So bringing together the pricing info from your order system, the carbon impact info from your fulfillment system or your supply chain system, the quality information from your ticketing or customer issue system, bringing all of that together so that you can make more informed decisions without having to navigate across all of those systems. And then providing personalized recommendations, insight into the trade-offs, making conscious trade-offs rather than having to optimize against one metric and maybe not understanding how that might affect another. So I'm going to optimize for assurance of delivery because I don't want to miss deliver. I don't want to be the buyer that causes us to miss a delivery to a key customer, but I've eroded the margin so much because of this this order for this supplier that we haven't had time to negotiate with. And so the company is not making any money on this order because we have undermined the margin here. And so this is one use case for this med tech manufacturer. Now, if we think about predictive maintenance coordination. Think about a factory line manager, right? They get an alert that, and this is a common capability, right? This machine learning model is looking at vibration and temperature and centrifugal force of a piece of critical equipment in this manufacturing line, and the line manager gets an alert that this piece of equipment is trending toward failure. So the line manager then has to swivel chair over and look at their production schedule. What products are going to be on the line that require this piece of equipment? They have to look at their staffing schedule. What staff is on when, who are assigned to use this machine in the manufacturing process, right? They have to then go to a ticketing system, find a window where they can request a maintenance tech to come and repair the machine within a certain window. And that is, a lot of judgment calls, a lot of data gathering, a lot of, chair swiveling for that production line manager, right? They have to swivel between their failure prediction system, their production scheduling tools, their staffing database, their maintenance request platforms. Each transition requires context switching, manual data entry. Back to the 20 to 30% of their time consumed just navigating across these multiple systems. The technical documentation that the tech needs is stored in different knowledge management systems. Repair logs that exist in maintenance databases that are disconnected from their training records. Technician notes are captured in various formats, emails, papers, tickets, with really poor searchability. The service team leaders have to manually review the technician availability and their capabilities. There's not a systemic matching of technician skills to specific equipment issues, and there's limited visibility into technician success rates with certain types of machinery or certain issues. There's also the siloed impact. The production impact analysis requires separate manual calculation. There's not an integrated view of maintenance timing effects on the productivity metric, right? If I take this machine down for this period of time, how is that going to affect my productivity metrics? And the line manager has to make subjective schedule trade-offs, without having comprehensive data. Then during the repair, the technician has to search through multiple information sources, the technical documentation for the machine, what are the standard readings, what previous repairs have been done on this machine, context from previous repairs isn't readily accessible, and there's not an interactive way to query the technical documentation on historical repairs, right? So has somebody repaired this machine recently for a similar problem? What did they do and how long did it take? And so, in the future, right, back to the example, very similar to the supply chain one. The manager gets the alert that the machine is trending toward failure. The AI agent has evaluated their production schedule, has looked at their staffing plan, and has identified 3 windows with a prediction of what products this will affect and what will be the impact of their productivity metrics. It automatically, the line manager knows that, okay, this person is going to be on this day, or I know I'm going to be out on this day and I don't want to have this happen while I'm gone, so they choose this window. It sends it into the technician repair queue. The AI agent there then takes that information, finds a technician who is on at that time, who has been trained on these repairs, who has experience with this sort of machine, who has good success metrics with this machine. The technician shows up. They have natural language query capabilities against both the technical documentation, the repair logs, and the notes from previous repairs so that it can synthesize information and provide recommendations to the repairing technician. So not only does it give the line manager more control over how his productivity metrics are impacted, it can also reduce the time window that that technician needs to repair the machine, because he or she has a much more robust set of information that they can draw from and in a very easy way to repair that machine. Now, to be honest, I said this is beyond chatbots. Technically, that is a chatbot, right? Now, it is a specially trained chatbot that has specific information and knowledge that it is using, but at the end of the day, it's a chatbot that repair technician is using. And so this is how, in this predictive maintenance coordination, and I changed it from optimization to coordination because it really is about coordinating across these different functions that are required to do this in the most efficient and effective way possible. And so, again, there are the more traditional dashboards and analytics that are involved in this, right? The health indicators. Organizations, manufacturing lines have this now. They're getting, when I worked with manufacturing line leaders, they are fatigued by the alerts that they get, and they're never really sure which one they need to pay attention to. They have, access to their production schedule and their capability, their capacity utilization, the technician availability and skills matrices. All of this is available, right? All of these metrics that they're measured by, they have access to these, right? The GenAI agent is just taking this existing information that's already available and optimizing, providing some recommendations to the human so that they can make the decision based on a much broader set of factors. The predictive analytics that they have, right? The failure models, the window optimization, the maintenance optimization algorithms, which technician is best for which piece of equipment or which repair. Parts inventory, making sure that the parts that might be needed for the repair of this machine with these sorts of readings are actually available before they take the machine down for the maintenance. And then these production impacts simulations. So, you see how GenAI is really, again, reducing or eliminating the swivel chair, coordinating across these previously siloed functions, extracting knowledge from unstructured systems and making it more accessible and consumable for people in the moment that they need it. Not sitting in a classroom training on these manuals, but having access to them through natural language in the moment they need that information. And again, this natural language guidance through the repairs. So why isn't everybody doing this, right? Yes, it is hard. There are a number of different categories of barriers. And I start really with what is, I think, most common and the biggest barrier are these strategic barriers. There are a lot of executives who don't, leadership teams who don't really understand how GenAI differs from traditional automation. They may be doing, a lot of robotic process automation, but they don't understand how much more robust and broad GenAI can take that. Very limited viewpoint. A lot of GenAI initiatives are treated as a technology project and not a business transformation. And when you have technology leading the way in something that should be business transformation, you're going to traditionally focus on cost and reliability and not focus on business value and the experience of the users who have to, that last mile Christoph was talking about, that user experience that has to be good to get the value from this, because all of this creates no value until somebody actually uses it. Again, this technology-first approach is a big problem. And we've seen this, right? This is not unique to GenAI, right? Think of every big technological advancement, I mean, since my 30 years in this career, right? Data warehousing, big data, digital, the internet. Just because it is delivered by technology, so many organizations think technology should lead the way. And that is a path to having a lot of bright, shiny objects that will take an extended period of time to create value. And then a lot of organizations struggle with how to prioritize use cases. I think really thinking about where those swivel chair processes occur and where you can reduce that swivel chair activity is a great way, another factor to include in that use case prioritization process. Other barriers, organizational barriers and challenges, right? So incentive misalignment. You think about, my performance rewards are based on how my organization functions. So if I'm a buyer and I'm incented on driving margin, reducing cost, assurance of supply, well, I may not choose the most reliable parts for engineering because engineering gets measured on quality and I don't, right? Process ownership conflicts, right? You heard how we went from planning to buying to engineering with the supply chain use case, right? From manufacturing to manufacturing line to repair in the manufacturing one, you're crossing processes that don't really have an end-to-end owner because we live, organizations still live in these siloed worlds of responsibility. Budget allocation models. I mean, I see so many organizations trying to figure out how to allocate money and how to measure ROI and getting really wrapped around the axle of trying to be overly precise with a transformative capability. Right? I mean, I've worked with some organizations and they're asking me, well, what sort of ROI should I expect from GenAI? I said, well, what's your investment right now? Well, they don't have any investment. I said, well, until you start investing, then we can start calculating some return. Technical business communication gap. Business needs are often challenging to translate into technical implementation requirements. I mean, basically my 4 years at Amazon Web Services, I was working with executives and technical teams doing exactly that through workshops because it is a challenge to get the business teams communicating in a way that the technical teams can really understand and getting them talking the same language on the same page. And then this expertise territorial defense, so many people, they see their value in the organization as their ability to navigate these systems to, I'm the fastest one who can go across these 15 systems. I've got my secret sauce in my swivel chair. I got a turbocharged swivel chair. And if you take that away, then my ability to differentiate my performance is gone. So you come in here talking to me about how you're going to automate this, I'm not going to participate. I don't want to be part of this. And that's really where a lot of these transformation efforts break down in that kind of middle management tier. And then, finally, technical barriers and challenges. Different systems using inconsistent terminology and data definitions for similar concepts. These operational definitions. I mean, I can't remember, I can't really estimate how many hours I spent at one organization trying to define what is a customer, right? You would think that would be easy, but if you were in finance, it was somebody who paid the bill. If you were in marketing, it was somebody that had an active policy, right? If you were in sales, it was the primary person on the policy, right? Missing contextual metadata, right? Legacy systems that have built up and nobody really knows what this code means or why are these values missing between April of 2022 and July of 2023. Well, you know, somebody in the tech group knows we upgraded the system then, and we didn't upgrade to the new version, and we had to reuse a column to carry a value for us, and so it didn't convert over to the new system, and so we lost all of that information. But really, when I think about the semantic misalignment and the missing contextual metadata, that's as much culture, right? That is this culture of data ownership, this culture that data has value, this culture that we need to, everybody is responsible for the quality of the data within the organization, right? And so that's as much culture as it is technical. And then you've got format inconsistencies, and then, you know, systems that really can't handle the increased query volume that comes from GenAI integration. And so these are really a lot of the big challenges that organizations face. But, you know, the steps to make progress, my Amazon colleagues will recognize our flywheel. I still think this was something we used when I was at AWS, and it's really taking an iterative approach to how you go about this, right? Start with a high-value use case as the focus, right? Move from thinking of GenAI projects to I'm building a GenAI product, and have that product management mindset where you focus on the user's experience. You get feedback, both digital and human feedback on that experience. You analyze that data and you enhance that product. And so you improve iteratively as needed for specific outcomes, but you plan for reuse. Build cross-functional teams and governance structures, but make sure they're fit for your current situation. I see so many organizations spending 6 months on a GenAI governance plan that they're planning for some future state when they think they're going to have, these 15 AI agents running one function, and they're tripping over themselves to get the first pilot of GenAI capabilities in place, right? Create these governance, oversight, regulatory management, risk management structures that are fit for your current level of maturity, knowing that they will need to evolve and be enhanced over time. And then finally, feedback loops for continuous improvement. You've got to understand what's working, what's not, double down on what's hitting the mark. Invest in understanding what's not, how to fix it. Do we fix it? Do we jettison it, right? The feedback loops have to be architected in from the beginning, or else you're going to be making decisions on your GenAI products without any really quantitative or accurate data. And so it just blows my mind that you would invest in all this technology to improve decision-making, but not architect in the foundation that's needed so you can do data-driven decision-making on the value that the GenAI capabilities are creating. And so, the key takeaways from this is, as an integrator, GenAI really is a multiplier, can serve as a multiplier across your siloed analytic investments, right? It's not about redoing everything. It's using GenAI to connect information across these siloed analytic investments. You've got to blend traditional analytics with new AI capabilities. The traditional analytics are not going away, and those of you who work on those, you are still going to be needed in this new world of GenAI, because these are the foundational capabilities that enable GenAI to function. And the competitive advantage will go to organizations that see, GenAI as a business transformation, not a technology project. And that is really critical. Business value and capability first, and then the appropriate technology that's needed to enable that.